Now we are going to discuss about the synthesis of diphenhydramine and metpyramine. What is this diphenhydramine and metpyramine? These are all coming under the category of antihistamines. Before going into this synthesis, we have to know what is this antihistamines. See, antihistamines are the drugs that compete with the histamines for their receptor sites, namely H1 receptor and H2 receptors. So these antihistamines will compete with the histamines for the receptors H1 and H2. What is this H1 receptor? They are found throughout the body, whereas H2 receptors are located in the gastric mucosa. Okay, so histamines, if they bind to that particular receptor, it will produce some allergic reactions. That's why it will cause some allergic reactions, and H2 receptors means that will increase the gastric acid secretion. So usually antihistamines will compete with the histamines for their sites to produce its action. What are the uses of this antihistamines? See, all the antihistamines, they are used for the treatment of allergies, especially nasal allergies, and it is also used as an anti-emetic, and it is also used in the treatment of Parkinsonism. So one of the drugs, that is diphenhydramine, we are going to discuss, that is used for the treatment of Parkinsonism. Let us see the synthesis of diphenhydramine. This is the structure of diphenhydramine. So it contains two phenyl groups, hence it is diphen, and amine group is present. So diphenyl methoxyethyl N-dimethylamine. This is the IUPAC name of this diphenhydramine. So it is also used as an antitussive, anti-emetic, and it is also having the sedative properties. So what is the starting material for this synthesis of diphenhydramine? So we will see this structure. This is already we have studied in our POC, that is diphenyl methane, C6H5, CH2, C6H5. So it is otherwise known as biphenyl or diphenyl methane, which are treatment with the bromine. So one hydrogen will react with the bromine, that will be eliminated as hydrogen bromide. So bromine will be attached, so it will give the C6H5, CHBr, C6H5. The next stage is we are doing the oxidation with the potassium dichromate, and we are also using the compound NN-dimethyl amino ethanol. So here NCH3 CH3 will be present. So CH3 CH2OH means it is ethanol. One hydrogen will be replaced by this dimethyl amine. So hence it is known as NN-dimethyl amino ethanol. What will happen? One hydrogen will take the bromine, that will be eliminated as hydrogen bromide. So remaining our product will be formed. That is C6H5, CH, C6H5, O, CH2, CH2, N, CH3, CH3. So diphenhydramine will be formed. The next drug will be metpyramine. So it is also having the same structure as that of diphenhydramine, but there is a small change in that one. Here we will find that instead of CH, we will find that CH2, C6H5O CH3, that is methoxy group will be present, and one pyridine will be attached. So it is known as pyrilamine or metpyramine. That is methoxy group is present and pyridine group is present. Remaining things are same: CH2, CH2, N, CH3, CH3. So what is the use of this pyrilamine or metpyramine? It is used in common cold and menstrual symptoms. So apart from that common cold, it is also used for the menstrual symptoms also. Let us see the synthesis of this metpyramine. What is the starting material of this pyrilamine? We are taking that, as the name suggests, the starting material will be pyridine, which are treatment with the sodamide. It will give, we have discussed about the reactions of pyridine. In that one we might have studied. In second position, amino group will be attached. So it will give 2 amino pyridine. So pyridine and treatment with solamide NaNH2, it gives 2-amino pyridine, which are treatment with NN-dimethyl amino chloroethane. See, Cl, CH2, CH2, N, CH3, CH3, which will give the NN-dimethyl amino chloroethane. What will happen? Here one hydrogen will take the chlorine, that will be eliminated as hydrogen chloride. What is remaining? So NH will be part to the pyridine, NH group will be there. Then CH2, CH2, N, CH3, CH3 will be there. So the next step is we are treating with the para-methoxybenzyl chloride. So C6H5CH2Cl, it is benzyl chloride. To that we are adding the methoxy group in the para position. That one is known as para-methoxybenzyl chloride. So here one chlorine will take one hydrogen, that will be eliminated as hydrogen chloride. Our product will be formed, that is C6H5. In fourth position OCH3 group is present. Then CH2, N, CH2, CH2, N, CH3, CH3. Here one to the nitrogen pyridine is attached. So methylamine will be formed. So this pyrilamine, it is used for the common cold as well as menstrual symptoms. I hope you could understand what is antihistamines, how we can synthesize this diphenhydramine as well as pyrilamine. Thank you.